All right, so today we're going to look at our last way of factoring trinomials and binomials. So we're going to be looking at factoring our special cases. So recall from 7th 3, when we were multiplying special cases, we could do a plus b quantities squared and jump straight to a squared plus 2ab plus b squared. And then the same thing if we have the quantity a minus b squared. It gives us a squared minus 2ab plus b squared. And then lastly, if we had the difference of squares, a plus b times a minus b, we can do a squared minus b squared. So with these, a lot of you did choose to FOIL, and that's fine. When you're factoring, you can still do AC factoring if that's what you prefer. But we're going to go through and show you how to use these special cases to kind of do a shortcut. All right, so the first one, if the first and last terms of a trinomial are perfect squares, and the middle term is twice the product, so multiplying, of the square root of the first and last terms of the trinomial, then it is a perfect square trinomial. And that is where these formulas come from. So if we look at this first one, factor the trinomial x squared plus 14x plus 49. So if we look at our first term, if we try to take the square root of x squared, we get x. And if we look at our last term, 49, it's a perfect square. And if we take the square root of 49, we get 7. Okay, so that's your first step. Check to see if the first and the last are perfect squares. They are. Now we want to check our middle term. So if we multiply these, so we're checking, if we do 2 times x times 7, so that first and last, do we get the middle term? Well, 2 times x times 7 is 14x. Does that match? Yes. So that works. So that means we can go further and just go straight to our factored form. So we're going to bring down our x, bring down our positive 7, and write it as a squared. So that works. And that's your answer. So it's a fast way to factor. So let's look at b. So if we look at our first, 9x squared, take the square root. So the square root of 9 is 3, and the square root of x squared is x. Then look at the last. The square root of 25 is 5. And now we want to check. If we take 2 times each of those square roots, do we get our middle? So 2 times 3x times 5 is 30x. Does that match the middle? Okay. It's really close. It's just missing that negative. Which means when we write our product, we're just going to make it a subtraction instead of an addition. So this becomes 3x minus 5 quantity squared. Okay, so again, you can choose to do AC factoring here instead of using the shortcut. The only problem with this is when you do AC, for like this example, we get 9 times 25. Well, that would give us 175. So if we have to find all the factors of 9 times 25, which actually, let's make that 225. Sorry about that. Helps if I can write the right number. Okay. Well, do you know the factors of 225 off the top of your head? No, that's a longer list. So that's why checking to see if this method works is more beneficial. All right, so we're going to leave C and D for you guys to try on your own and talk about in class. Now let's look at difference of two squares. So if the first and last terms of a binomial, so remember a binomial, we're looking at two terms, are perfect squares and they're being subtracted, then it is called the difference of two squares. So if we look at this first example, 9x squared minus 100. So I'm going to take the square root of the first, and we get 3x. And then I'm going to take the square root of the 100. We're going to ignore the negative right now, and we get 10. And then we are subtracting, so that's good. So we can jump straight to our answer. We have two binomials, 3x plus 10 and 3x minus 10. Okay. All right, now let's look at B. We have 3x cubed y minus 12xy cubed. Well, on this one, we can't take the square root of 3. Okay, that doesn't work. But we do have a subtraction of two terms. So let's check, is there a GCF? Well, 3 and 12 are both divisible by 3. Our lowest exponent for x is x, and our lowest exponent for y is just y. So let's factor that out. So we have 3xy times the quantity 3x cubed y divided by 3xy is just x squared. And then negative 12 divided by 3 is a negative 4. Our x's cancel, and we're left with y squared. Okay. Well, now notice we have x squared and y squared. So let's check and see, can we take the square root of both of these? So I'm going to write this off to the right. So the square root of x squared is x. So that works. And then the square root of 4y squared is 2y. So that checks. So we can rewrite this. 3xy are two binomials, and we have x plus 2y and x minus 2y. Because we're always going to write a positive and a negative for those binomials. All right, so I want you to try C and D, and we'll go over those in class tomorrow.